Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Okay, so we are on our fourth image classification tool. So we've done pronunciation again. Wait for it. Where did I know? Jetsaka tool. Okay, so we've done the Jetsaka tool, then we looked at the supervised classifier, and then we just now did the classification tool. Okay, so we're sitting with a spreadsheet that roughly looks something like that. The Jetsaka classifier, classification tool, and now we're getting into number 4. Okay, so which is next? Which is number 4 on our list? We're going to work with the neural network classifier. Neural network classifier again. It's a plugin. Go to manage and install plugins. Go and look for it. Neural, there it looks something like that. There's all the details of where to find it, the codes, and all this sort of things. Okay, so go and have a look at it. Very useful information. The homepage looks something like that. Remember, there is some Python codes that you have to install to make sure that it's working. There's all sort of the select no data training set, use the argument no data. So run through it because it's quite a tricky one to do. Okay, there's quite a tricky one to do. It's got some nice content as exercises and the classifier, etc. So go and have a look at it. It's useful information to get going because it is a tricky one. It's not an easy one. It is a tricky one. Again, similar to the previous one, it's got parameters on parameters on parameters on parameters. Okay, so let's get going. Please, boys and girls, like and subscribe. Please, let's grow the channel together. Okay, so this most probably will be a 3-part series. Most probably be a 3-part, where the others were predominantly 2-part. This most probably will be a 3-part series because it's quite a tricky one. The first trick, the first important part is if you open it, is your training image. Remember, we've been working with the vector, this one here, up to now. Okay, we need to now convert this training vector shapefile into a raster. Now that's easier said than done. Why? Because these two, the image, remember our image is our stack, our Sentinel stack. Sentinel band stack raster, and that's the one that we generated through our supervised classification plugin. Remember bandset 1, where we have all our bands, and we created the bandset here. So remember, that's the bandset. Now that bandset has a specific extent. Okay, for simplicity, I've copied the extent here. Let me just make it a little bigger. Okay, there is its extent. It has a Y max and a Y minimum, and it has an X max, or is it the other way around, and an X minimum. I think this is X maximum, X minimum, Y maximum, Y minimum. It's width, length, and it's a float 32. So that is the extent that our training raster must have. If it doesn't have this, it will not work. Promise you. It's very finicky. It needs to be absolutely 100% the same. If there's a missing number, so if that was a 5, if that's a 5, one small little deviation, then the thing is going to bomb out. If our raster or our training raster must have exactly this extent. If not, you'll see now I'm going to give you an example. Okay, so let's go and have a look. Where is our training file? There is our training file. Okay, there sits our training file. Now, I'm not going to use the normal rasterized conversion, rasterized vector to raster on these functions. I'm going to go use my SCP doc. I'm going to use my SCP doc. Okay, so within my SCP doc, okay, I'm going to go to vector to raster. So I'm converting and amending my shapefile, my training vector shapefile. I'm going to do all that work in this SCP doc to make sure that the extent is the same. Because we've created the band stack, we created that in the SCP doc. So it just makes sense in my mind to also then use the same tool to convert the shapefile into a raster, because as I said, we've done it in this band stack. Okay, so first thing is go to select the training shapefile that we've been using. If it's not there, just click on this little button there and hit refresh. Give you all of the shapefiles, and you select the one. Remember, it's the value, it's ID. Leave that the same. Use the extent same as the raster. Now here is the interesting part. Okay, so I'm going to do this in twofold. I'm going to first rasterize it based on, you see, if we don't have the band stack here. You see, you don't have the band stack here, so we can't use this, the band stack extent, the band stack extent, because it's not here. Now, interesting enough, you'll see that the band stack, which is the one that I just showed you, the extent, if you go to information, there it sits. 1876, so just basically memory quickly, 1876, 1876. Okay, 1876, 1876. So that's the extent of the Sentinel band stack. But if I go to the individual rasters, we go to that, you'll see it doesn't have that 1876 again. And therefore, it's got all the other information is exactly the same, except this one. And therefore, it's not going to work. So we need to convert this training file into exactly the same extent as our band stack raster, but our band stack raster is not available here. So I'm just going to use the Sentinel band, any Sentinel band, because they all have exactly the same extent. So the Sentinel one. And minimum, and then important, use minimum extent, etc., etc. And then you simply just run it. Okay? Then you simply just run it. And it's going to convert. You say run. It's going to ask you the file name, blah, 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 blah. I've already done that. And it sits there. There's my training raster. Now you'll see it's exactly the same. It's exactly the same as my training. No difference. Except I don't have the colors here, but you can see if I go in, there's my raster, there's my shapefile. There's my raster, there's my shapefile. Okay, but now this raster that we've created doesn't have the same extent. You can see the extent is different, the width and the height is different, everything is different, and more importantly, it's an integer 32. Remember, we need to get a float with a width of 973 and 822. Have a look here. Where is it now again? Sorry. It's 8766, so the whole thing is wrong here. So the whole thing is wrong. So let me show you. So if I use the training raster, we're just going to go to neural networks, and I'm going to say I'm going to use my band stack, and then I'm going to add that training raster. See, no shape files, only Where's my training raster? There's a training raster. Leave all the other stuff, no data. I'm just going to make a 0. Otherwise, that will be the reason why it throws it out. And I'm going to run. You see, it will say, all images must have the same number of rows and columns. So you're going to keep, it doesn't matter what you do with all these parameters. These two files have different extents. And that's why you're going to get, and this is basically what it means. All images must have the same number of rows and columns. Must be exactly the same. Can't emphasize it. And that's why you get this red. So if you get this red, you know that these two does not gel. They don't align. They don't have the same extent. Okay, so now I've converted the vector into a raster. Now I need to take this raster and get it into the same shape, same extent as my band stack. But I said this band stack doesn't feature in the SCP doc. So how we're going to do this, we're going to go into reproject raster bands. Okay, so first of all, I'm going to create a second band. I'll just use this button. And I'm going to add that training, the one that we just created. I'm going to add in as a second band, as another band. Okay, so you go to band set. If it's not there, you click on the plus, and then you go and look for it. There it sits. So you did, and okay, I've already done that, and there it sits. And that's now going to be my second band. So now I've got two bands. I've got the band stack, and I've got my training band, a training raster. Now these two need to be exactly the same extent, but this band stack is nowhere to be found in any of my options. Fortunately, these classification images that we've created, these ones, they do have the same as the Sentinel band. So for example, if we look at the Tzaka-Gaussian, remember the 1876, 1876, exactly the same. So there lies in our solution, is to use one of these image classification images as our reference, because the band stack, the stacked layer, we can't use it because it's not a reference. And we can't use our Sentinel bands, our individual bands, because it doesn't have the same extent. So we're going to use one of these. We're going to use one, and you'll see they all have the same. Let me just quickly say classification 2. Let's look at this one. Yep, 187. So all of these image classifications have the same as the band stack because they derive from this band stack. So we're going to use one of them. So I'm going to go into my SCP doc. But as I said, first I have to make sure that the training raster, the one that I just converted, is in my bands. So that's the first option. First thing, I have to make it sure it's in my bands. Then I'm going to go to reproject raster bands. And I'm selecting band 2. Because what I want to now, remember we've taken the shape file and we've converted it into a raster using the individual Sentinel bands. But that doesn't give us the same extent as the stack raster. But fortunately, we've got those image classified images. They do have the same extent as the stack raster. Now, if you look at here, it says the same as. So remember to make sure that it's selected 2, because that is our band set. Okay. So please remember to make sure. Then I'm going to align it and use the same extent. And you see, you see the stack raster is nowhere to be found. It's not here. It's not here. So I cannot align it to the stack raster directly. So I'm just going to use any of these image classifications. We've already said that the Tzaka-Gaussian has the same. So we use that. Change input data to no, change output no data value. Make that 0. So make sure it's ticked. And then here, output type, make it float 32. Remember, our data is float 32. So remember, we're going to use one of our image classified images for the extent and for the width and the height, and then within that tool we convert it to a float 32. So now theoretically it should be exactly the same. Give it a name, output, I'm just using REE. Make sure there's nothing weird, nothing like that. We're going to run it and we're going to save it in that. It's going to give you the t sounds and all these things. Yeah. And it should be done. And there it is. And there it is. Okay, now right click on it, properties, and you see it's 1876, 1876, 973, 822, float 32, which is 1876, 1876, 973, 822. Like that's your 508, 133, 508, 133, 508, 133. Now we have our file, our training file. I'm going to delete these ones. Remove. Now we've got our training raster. There it is located. There it sits with exactly the same extent as our stack raster. They're now exactly the same extent. It took a bit of time and effort to get there. But we have no choice. Otherwise, we can't use the tool. So there it's at. Okay, so now let's have a look. I'm going to go to my stack raster. And I'm going to go into my training raster. Just going to remember we made no data 0. So make it a 0, leave all the others the same, run, and voila, it's working. It's working. Okay, it's working. So these two things has to be exactly the same. If it's not exactly the same, it will tell you, sorry, no go, cannot work, it's not going to happen, see you later, start all over, come back when you're ready, however you want to call it. Okay, so that's your first step. Let me just delete it, remove it. That's your first step. That's your first step and your most important step. Then if we quickly look at the classifier, okay, so now the SCP doc has done it. I haven't found any other way to do this easier, quicker, better. It makes sense to the way I've used it. If you have a better way, easier way, quicker way to do it, that's fine. It's a bit of a process, but it works. So I'm just going to delete that. Let's go into the neural classifier quickly. There's our image with the stack one that we're going to select. There is our training one, the one that's now exactly the same. So said these two must have exactly the same. When I mean exactly, you've seen it exactly the same. No data. Remember, we've made our, let me just go back into the SCP doc again. SCP doc. When we go into pre-processing, reproject, remember we said change output no data value to 0. Okay, so we change it to 0. And so therefore no data has to be 0. So those two things must be the same. Then the number of hidden neurons layer. And there again, there's no specific. You see, if you read the comma separate files, the eth element represents the number of neurons in the eth hidden layer. What exactly is, I don't really know. Play around with that. Maximum iterations, that's how many times you're going to train the classifier. Test size, proportion of training pixels will be used to evaluate the train. So it is 0 or 1. You can't really do anything else than 0 and 1. Then the functions. Here we've got the parameters. Logistic, identity, tau, relay, relu. Some of them work, some of them don't work. Your probability of the selected class and the plot of your the file and your output file. predictability, predict the probability class. Instead of classifying the image, each image pixel predict the probability of finding the class. File plot is used following the seed. Random number generator is 100, the constant learning rate, 0 tolerance of optimization. But I'm sure if you study the guide, some of these things will become more useful for you. Okay, test size 0.33. 100 is full test. 0 is, so we're going to say 0.2. So that means 20%. 0.2. Oops, he doesn't want to do comma, so what does we do? It's a point, yeah. So it's also so these things are 0.25 test size. Not sure why it doesn't want to do that. We'll figure that out in the next video. Anyway, just giving you a background. And so here again, it is the number of parameter options you have is significant. So you can generate a hell of a lot of them. We're going to try to keep most of it fairly stable and then just use these functions and see what happens with these functions. Okay, if you play around, in fact, you can play around with this. Every time you'll get something new, you get something new. I said, you can really never-ending story, so to speak. So there has to be a bit of sanity now and again. This is an important part. Well, in fact, all of them are important and stuff. Okay, so that's going to be our next video, is to play around with this and see what we can figure up, what we can get to. There's just a sample of it. This is what I get. 1, 2, 3, 4, 5, 6. That's how it looks. One of them. That's a classification that we've got and that we've done. So very similar to our other images. Gives you this purple background. So if we do that, that is value 3. So for whatever reason, the background is the value 3. So remember, we're going to have to then calculate the actual value of number 3, which is mountains, when we do our Excel data. Okay, so that was just a quick video, just to quickly inform you about the importance of the conversion of your vector, training vector, into the training raster, and the issue of the extent and how you deal with the extent and what the extent means, how you deal with it, and if it does not have the same extent, it's not going to work. Okay, so with that said, watch out for the next one, where we're going to go into the classification process itself using our neural network MLP classifier. Okay. And that is tool number 4, and we're going to most probably do see if we can get 4, if we can get 4 out of it. I'm not sure whether we're going to be how many we're going to get, but again, I think a nice one will be a minimum of 4. With the classification, we went a bit more, but it's understandable. The neural network, will see if we can get at least 4 classifications out of this tool as well. Okay, so with that said, thank you for joining me. Thank you for your well wishes and nice comments and thank you notes and all sorts of things. I really appreciate it. Please again remember to smash those buttons, like, subscribe, share. Let's grow the channel together. Let's explore it together. Let's make it happen. And with that said, I'll see you on the other side.